This video will be explaining question 10 from the chapter 1 through 2 Cumulative Review. Question number 10 gives us a data table of total revenue values for Apple over the past several years. Notice it says years since 2010, so the 1 here would mean the year 2011, the 2 would mean the year 2012, 3 would be 2013, 4, 2014, and 5, 2015. Most of the questions will define T to be years since a specific year, so please read questions carefully and look for that description of your input value. The first step here is that it's asking us to write an equation. So I always start whenever given a data table by plotting the data points in my calculator using a scatter plot. So as you can see here, I created a scatter plot of the data and I adjusted my window, and I wrote the window I used down here with my x-min being -2, my x-max being 6, going up by 1s, my y-min is 0, my y-max is 250, going up by 25. And these points here represent the data points in the table. Our horizontal axis is the T, or the year since 2010, and our vertical axis is the revenue in billions of dollars. I also went ahead and sketched where I thought a good line of fit would be. So the best line that would come as close as possible to all of the data points, making it so that there's an even distance above the lines as there is below the lines. And once I draw this line, this will help me decide what 2 points I want to use in order to figure out the model or the equation for this data. So here is a data point and here's a data point. These are the 2 I chose to use. This would have been a fine choice as well, but I chose the data point for 1,108.2 and the other data point, which was 3,170.9. If you wanted to, you could also use linear regression on your calculator, which would find an equation that would come close to all of the data points, and it would have slightly different values. I'm going to go with using these 2 data points so I can demonstrate how to find the equation of a line given 2 points. First thing I'm going to do is find the slope of these 2 points. And to do that, I do the change in y and then over the change in x. And it really doesn't matter which one you call point 1 and which one you call point 2, just that you have your y's over your x's and that the points line up on top of each other. So I end up with 31.35 for my slope, and then I used point slope form to find the equation, but you can by all means just use y equals mx plus b and substitute a value in for x and y, which has to be one of these 2 points. So I chose to use the first point, and I plugged in the 108.2 for y1, and I plugged in this 1 value for x1. So now that I have my point in there and I have my slope in there that I found, I'm going to distribute the 31.25 through, so I get 31.25 times x and 31.35, times -1. Now if I want to get it in slope-intercept form, I'll need to add the 108.2 to both sides, and I'll result with y equals 31.35x plus 76.85. But since it's asking us to do r of t, we're going to let t be our input variable. And when we write this in function notation, it would be r of t equals 31.35t plus 76.85. I did jot down here what it would look like if you did regression on your calculator, but I'm going to use this blue function here for the rest of the problems. Okay, so for the next problem, this is what's the vertical intercept? We know the vertical intercept is happening when our input value is 0. So they're asking us to find the output value when t is 0. And they want us to do this for our model. The model is the equation that we found in part A. So using that model, r of t equals 31.35 times t plus 76.85, I need to find out when t equals 0, what do I get out? So if I plug 0 in for t, I'll get out 76.85, which was also easy to find because it's in slope-intercept form. So this is the ordered pair that represents my vertical intercept. And when I go to interpret them, I like to put them in my table so I can say, okay, 0 years since 2010 gives $76.85 billion in revenue. And it helps to write the sentence when you think about what they look like in your input-output table. For question C, it's asking for a reasonable domain and range. So first thing I'm going to look for is where is the model breakdown occurring, because I want to avoid that. And model breakdown would be if I'm getting negative amounts of money out, revenue out. So I probably want to avoid that. So I started at -2. You could have also found where the horizontal intercept is by finding when your function equals 0, and you could use that as a baseline. So I said starting at -2, and the output at -2 is 14.15, and I jotted that down over here. So then you can continue. Now our data goes to the year, I think it was around 2005, or sorry, 2015. So our data is covering up to about here. So we can go a little bit further. We just don't want to go too far away from what our data gave us, because the data, the further we get away from the data and extrapolate further, we tend to introduce some error. There's a lot of things that could happen in the world, obviously, that could cause, if we look too far in the future, for our results not to be very accurate. So I just went a couple years, but really that number 7 could be an 8 or 9. That's not in stone what that value is. So at 7, I have an output of 296.3, and I wrote those down there. So the values under T are our domain, and under range are the ones under R of T. So our domain is the inputs, the range are the outputs. So I wrote them up here like this. And the bracket means I can include those values. And how I get these values is I just look at -2, what's the output for -2? I look at 7, what's the output for 7? And that's how I got my range. Again, this doesn't have to be -2 to 7, but if this changes, these need to match whatever the values are you have over here. And I would try to avoid getting negative outputs. So you probably want to make sure that you're doing something like -2 or higher as your domain. For Part D, estimating the total revenue for the company in 2020. Well, total revenue is our output, so we're trying to find the output, and they're giving us an input value. 2020 would be the year, would be 10 years since 2010. So if I look at it in my input-output table, 2020 is exactly 10 years since 2010. So a 10 goes in for T, and I'm looking for the output at that. So using function notation, we're looking for what R of 10 is, which means we just substitute 10 in for T. And I believe you get out $390.35 billion would be the company's revenue in the year 2020. For question number E, the letter E, when might the total revenue be $250 billion? So for this one, we're trying to find the input, and they're giving us an output. So if I put that in my input-output table, I have a question mark under T and 250 under revenue. Since it's in billions of dollars, I don't need to add all the zeros. I can just put the 250 in. So an output means I'm going to replace R of T in my function with the value 250 and set it equal to the rest of the function and solve. When you solve, I think you get approximately 5.5, which puts us between the years 2015 and 2016. We can also use our table to see that 250 would occur between these 2 years. So right in here is where 250 would be. And that tells me my answer would be between 5 and 6 for a t-value. Problem F is asking what our slope is and what does it mean in regards to revenue. So looking at our function, R of t equals 31.35t plus 76.85 from part A, we'll notice that the slope is the coefficient of our input variable, 31.35. So now what does it mean? So I kind of included over here both the graph, where my axes were labeled, my horizontal axis is 2010 for inputs, and my vertical axis for my output is revenue in billions of dollars. Or you could look at it as the labels on your input-output table. But using the labels for the output and the input is important when trying to write your sentence for the meaning of slope. Slope is a ratio of the output change to the input change, and using the units that go with your output and the units that go with your input will help you write a good sentence. So this was our slope, and the units for our output was billions of dollars, and the units for our input was years since 2010. Again, vertical change output and horizontal change input. And if you always put the label for your vertical axis here and the label for your horizontal axis here, it'll help you write your sentence. Since our slope is positive, we will be saying that the revenue is increasing. Now, if our slope was negative, we would say that it's decreasing. And we can easily see here in our line that it's definitely increasing. So the sentence for interpreting slope would be Apple's revenue is increasing by $31.35 billion per year. And that's this line right here is the per part. So again, looking at your input-output table or your labels on your axes will help you write your sentence for the interpretation of slope. Please let me know if you need any more help.